In the previous sessions, we have studied about submerged arc welding process as well as shielded metal arc welding process. In case of submerged arc welding process, the weld zone is protected by a flux. In case of shielded metal arc welding process, the weld zone is protected by gas which is formed due to burnout of flux coating on the electrodes. In this process, that is gas shielded arc welding process, a gas exclusively used for protecting the weld zone from the atmosphere. The gases used are inert gases. These are the inert gases which will not combine with any other elements. There are two types of gas shielded arc welding process. One is metal inert gas welding, popularly called as MIG welding, and second one is called as tungsten inert gas welding process. Let us understand how these two processes work. The schematic diagram of metal inert gas welding process is seen on the screen. This process makes use of consumable uncoated electrodes. Since the electrodes are consumable, it means that the electrode will act as a filler rod. And it is not coated, so an additional flux is required to protect the weld zone. In this case, instead of flux, a gas will be used to protect the weld zone. There will be no flux at all in this process. Usually copper wires are used as electrodes. Sometimes copper coated electrodes can also be used in the process. The weld pool is covered with the shielding gas. Instead of a flux, there will be a shielding gas which will be sent through the nozzle near to the weld zone. So this shielding gas will be protecting the weld zone from the atmospheric contamination. The gases like argon, argon-oxygen mixture and argon carbon dioxide can be used as inert gases. Let us now discuss the various components of MIG welding process. MIG welding process makes use of consumable uncoated electrode which is fed from the wire reel to the welding zone using the feed rollers. The wire will be passing through a contact tube. The diameter of the electrode wire will be around 0.6 mm to 2.5 mm. There will be a shielding gas which will be sent from the cylinders. The inert gases from the cylinders enters into the nozzle and from the nozzle it enters to the welding zone. The welding torch forms very important part of the circuit. The welding torch will be provided with a trigger which activates the gas as well as the electrode. This entire process makes use of DC power source. A reverse polarity will be used where the electrode will be connected to positive terminal and the workpiece will be connected to negative terminal. Since the workpiece will be connected to negative terminal, there will be more penetration of the metal inside the workpiece. Let us now discuss about the operation of MIG welding process. This process was initially used in the industries in 1940s. At that time, it was helium which was used as an inert gas. Since there is lot of issues in using inert gases like helium to weld carbon steels, the combination of inert gas as well as oxygen or carbon dioxide is employed nowadays. Before starting the actual process, the job has to be cleaned for the contaminants like grease, oil and dirt. Later, the power supplies including the electrode feeder is to be switched on along with the inert gas supply. Once all the power connections is on, the arc is made to stuck between the electrode as well as the workpiece. The arc starts melting the workpiece along with the electrode. The molten electrode then combines with the molten metal and fills the gap between the two metals. Simultaneously, the shielding gas covers the molten pool. The weld head is moved along the surface to finish the weld.
What is MIG welding? MIG stands for Metal Inert Gas Welding. The American Welding Society calls this process gas metal arc welding, or GMAW. You might also hear it called wire welding. In MIG welding, a thin wire acts as the electrode. This wire is fed from a spool mounted on a gun or inside the welding machine through a flexible tube and out of the nozzle on the welding gun or torch. The wire is fed continuously when the trigger on the welding gun is pulled. When this trigger is pulled, it also switches on the welding current and a shielding gas. An electric arc forms between this wire electrode and the workpiece and heats both metals above their melting point. These metals mix together or coalesce and solidify to join the workpieces into a single piece. The metal in these parts to be joined is called the base metal, and the metal that comes from the melting wire electrode is called filler metal. MIG welding always adds filler metal to the joint. Because the wire electrode melts as it's being used, MIG is called a consumable electrode process. Here's the MIG wire going through the wire feeder into a flexible tube or conduit liner. The liner goes through the hose or welding lead all the way to the torch nozzle. At the nozzle, the wire is fed through a contact tip and comes out at the point of the weld. Shielding gas is also fed through the welding lead. It goes through a gas diffuser and flows out of the nozzle. This shielding gas, which is often a mix of argon and CO2, protects the molten metal from reacting with oxygen, water vapor, and other things in the atmosphere. The shielding gas is stored in high-pressure cylinders like these. The pressure is reduced to a usable level by a device called a regulator. In MIG welding, all the machine controls are set on the machine itself. The most important of these are polarity, wire speed, and voltage. The trigger on the gun is just an on-off switch. For most MIG welding, the current is direct current, or DC. DC is like the current flowing from a car battery. One wire is always the negative, and one is always positive. In DC MIG welding, the electrode is usually positive and the workpiece is negative. The term DCEP is used, indicating that the current is direct current and the electrode is positive. This is also called reverse polarity, but DCEP is a more descriptive term. In an electric circuit, the current flows in a loop. In MIG welding, the current has to flow in a complete circle from the machine to the torch, into the work, and back to the machine. A work lead is clamped to the work to complete the circuit from the workpiece back to the machine. So, in summary, MIG welding is an electric arc welding process. It uses a consumable wire electrode. Filler metal is added automatically, and the shielding gas comes from a high-pressure cylinder.
Let us now discuss various advantages and disadvantages of this process. This process produces continuous welds. There will be no formation of slag since flux is not used in this process. This process can be used to weld metals of any thickness. Even both ferrous as well as non-ferrous metals can be welded. There are no chances of weld spatter as well as formation of weld cracks. Let us now see the disadvantages of this process. The process is expensive, and this process, the entire equipment, is not portable. This process is not suitable for outside applications because of the effect of wind. The wind may disperse the shielding gas. Being understood the advantages and disadvantages of metal inert gas welding, let us now compare and contrast this process with shielded metal arc welding process. Shielded metal arc welding process makes use of consumable coated electrode. Here the electrode is coated with the flux. In case of MIG welding, a consumable uncoated electrode is used. SMA makes use of either AC or DC power source, but in case of MIG, DC power source is used. In the previous process, the weld pool is protected by the gas formed due to burnout of flux. But in case of MIG, inert gas is supplied from the gas cylinders which will be protecting the entire well pool. Since there is a flux involved in case of SMA process, slag will be formed. But since there is no flux at all in case of MIG welding, there is no formation of slag. In SMA process, there will be spattering of molten metal which will not be there in MIG process. The equipment is portable, whereas MIG equipment is not portable, and in fact this process cannot be used in outdoor applications. More smoke is produced during welding in case of SMA process, but in the MIG process there will be less or no smoke at all will be produced. Instead of smoke, there will be a gas which will be shielded over the entire well pool. And the last one being the well quality of SMA will be very much less compared to MIG process. Thank you for being here. In our next presentation, let us understand how TIG, tungsten inert gas welding process will work, and will also compare TIG with MIG. Thank you.